Hi, good evening, everybody. Uh, if you're joining me for the first time, my name is Anand. Welcome to Eptitude. Welcome to the IPM Booster series, lecture series. And we're trying to sort of build towards the IPM exam and practice, some of the most important topics. Today we're going to cover, one of the major troublesome areas, I would say, in calculus. This is the topic of limits and limits and continuity. And yes, so is it an important topic? If you're a student looking at, the IIM exams, IIM Indore, IIM Rohtak, or the DU-JAT, then calculus in general is quite important, right? It's a topic which attracts a lot of questions. So from that perspective, I think even limits, I should think that it's not that important at least from an IPM perspective. But I mean, there have been, there are a lot of questions from calculus that come, and so limits is definitely a topic which you should watch out for. Besides, it's quite a straightforward topic. I mean, I'm sure most of you will disagree, but I think limits are, there are fewer sort of approaches that are available, more formula-based sort of questions that come from this topic. So easier to handle, right, is the perspective that I have, right? If you're joining us for the first time, I urge you to subscribe to our channel. We're going to keep posting tons of content that is relevant for a variety of exams in India and abroad. Specifically, in catering to law exams and management exams. So do subscribe to this channel and do click the bell icon so that you get notifications about the sessions that we conduct on a week-to-week basis. Right. So some of my regular students are joining us. Hi, Anand. Right. So this is, calculus, I find, is one of those topics which, people in general, a class 12 student, tends to initially dislike, tends to initially fear, because none of it is, something which is studied in junior classes. But if you, if you study all of the topics in class 11th and 12th, then you find that calculus is actually not so bad. It's actually one of the easier topics, right? Because there are tougher sort of areas like, complex numbers or vector algebra or even, trigonometry. And so I think perspective, calculus is easy. It's scoring. It's quick. It's not very time consuming. It's when we're not, expecting questions from differential equations. So it's not going to be your lengthy question type, right? It should be definitely, in fact, all of the topics, all of the questions that we're discussing today, most of them at least, if not all, can be done in a couple of minutes or so. Good evening, Ayush, Arushi, and Nandini. Thanks for joining us today. All right. So I was saying, yes. So from that perspective, I think it's a very important topic. I hope that everybody's who's listening in, I hope that you visited the link that I've put up in the description. That's the link that you need to visit to access the class exercise for today, right? And I hope all of my students have already opened it up in front of you. I know some of you are sending us messages saying, why don't we allow exercises to be downloaded? Why are we not sending it across by email? And so yes, point duly noted. We will try and build that functionality, but for now, please understand that we prefer a system where all of the practice material is available in one resource, and that's going to be your online account. And I'd rather make you visit that online account so that you can access both class exercises and the practice material, and take mock tests as well, right? So my personal preference is to make each one of you visit the online testing portal after attending the session. Then if that becomes a habit, then you're going to find that there's tons of content that we've put up on our online portal, which could be quite useful. Okay. I think we can start today's session at that note. I again repeat, if you haven't already registered, then and I'd urge you to sort of subscribe to our channel. It's one of those, we definitely will be posting a lot of interesting content. Okay, let me quickly sort of access the exercise for today's session. This is from the chapter of limits and continuity. Okay. Question number 1, everybody. Question number 1. Can you guys try these? Try this question. Right? This one is limit. Find the limit of sin x raised to the power of x. How do we do that? What would you guys mark? That was a very quick answer, Anand. But I wonder if it's a tukka or did you calculate? Right? I wonder. You guys are able to hear me loud and clear, right? I mean, this is a question, this is the kind of question that you should be anticipating in, a tougher exam like a DU-JAT or even one of the IIMs, right? Because it's not a question which you can directly solve by using one of the properties of limits, right? And because here's the question, right? Limit x tends to 0. We want to find the limit of sin x raised to the power x. Yeah. And I mean, if you think about it, do I have a limit identity for sine? Yes. Limit of sin x upon x as x tends to 0, limit of sin x upon x would be equal to 1, right? But then that's sin x upon x. This is sin x raised to the power of x. So to solve this, to get this, what you do is you assume this limit to be n, right? And you take a logarithm on both sides. Right? That's our way of simplifying the expression, right? So let's try and do that. And obviously I'm relying on you guys knowing a little bit of calculus at this point because I need to differentiate both sides. Sorry, I need to take a log on both sides for now, right? So what happens if I take a log on both sides? So here I'll set log of a limit as x tends to 0, sin x to the power x. And clearly in simplifying this will be equal to log of L, right? And in simplifying this, I can take the log inside and log of sin x raised to the power x, you will end up getting the power of the exponent outside, and this becomes log of sin x, right? So this is like the first step, right? Now that I reach here, what should I do next? Right? The moment I get here, right? So I'm going to think, okay, what happens? And usually that's the first thing you should be doing, right? When you're calculating a limit, you try and substitute that value. What happens if x tends to 0? What if x is 0? This is 0. And log of sine 0. What is sine 0? Sine 0 is itself 0, right? So log of 0. What power of, what is the base here? Since the base is not mentioned, this is 10. So what power of 10 makes 0? Okay, minus infinity, right? Because if you're thinking 10 raised to the power something is 0, you'll say that something has to be a negative value, right? Because you want 10 to decrease and become 0, right? So it has to be a negative power. So in fact, it's a very, very large negative power is 10 to the power minus infinity, right? So I mean, that doesn't make sense. 0 into infinity kind of a form, right? In fact, if you rewrite it this way, then this has the infinity by infinity form, right? And what method do I use when a particular limit becomes either the infinity by infinity form or in the 0 by 0 form. What is that? What is that rule that we tend to use? Very, very critical rule, very useful rule, especially in such competitive exams. And it's a rule that you guys would have definitely studied at school. What is that? Come on, guys. You guys have done this at school. It's a rule that you must use when a particular limit becomes in the 0 by 0 or the infinity by infinity. Yeah. Well, Siddharth, I thank our blessings that after a long time you're attending a live session. We really feel blessed. Yeah. No, I'm just kidding with you. Right. I'd love to for you to be attending more of these sessions, but man, that's okay. As long as you participate in class, I don't really give a damn. Yeah. Live देखो या बाद में recorded देख लो, it's to me it's one and the same. But yeah, live is more fun because then you guys can participate. You guys can tell me what your thoughts are. Like for example here, what do you do? What do you do when you have a 0 by 0 or the infinity by infinity form? Come on. What rule is that? What is this? Remember this? The L'Hopital rule? You guys remember this? Whenever a limit, the L'Hopital rule says whenever a limit is in the 0 by 0 or the infinity by infinity form, what do? You basically differentiate both numerator and denominator and then try calculating the limit, recalculating the limits, right? If a limit on evaluation comes out to be in the 0 by 0 or the infinity by infinity form, then the L'Hopital rule says that all you need to do is differentiate the numerator and the denominator separately, right? So the moment I come here, the moment I figure out that this is in the infinity by infinity form, I'll know my very next step would be to differentiate the numerator and the denominator. So log L, which was anyway there, should now be equal to the limit when I differentiate the numerator. Now, obviously, you'll need to know how your differentiation, right? You need to know your differentiation. So when I differentiate a log, it becomes 1 upon that. So it becomes 1 upon sine x, right? But then, obviously, the chain rule for differentiation happens, right? Because if I'm differentiating this, first I'll differentiate this, and then I'll differentiate it's a composite function. It's a function of a function. So I'll go deeper into the function. So first thing becomes differential of log becomes 1 by sine, and then differential of sine is cos x. Yeah. And then what is the differential of 1 by x? That will be minus 1 upon x square, right? So that this is where I go. Yeah. And obviously at this point, I'm going to try and use as many properties as I can, because first thing is, what is the limit of cos x as x tends to 0? That's 1. Similarly, what is the limit of, so I'm going to take this, x square comes in the numerator, doesn't it? So this is like x square upon sine x. So I'll say, okay, what if I write this as x upon sine x into x, and obviously minus, right? I know this is 1. Limit of cos x will always be equal to 1. Similarly, limit of x, as x tends to 0, the limit of sin x by x is also 1. So this will be the inverse of 1, right? Okay, so that's also 1. And what about the third limit? What happens when x tends to 0? This becomes 0. So the product actually becomes 0. And so what I've got to do is that log of L is 0. And this is obviously with same base that I'm continuing to use, 10, which means L will be taking an antilog, L will be equal to 10 to the power of 0. So 10 to the power 0 is L, which means L will be 1. So the answer, Arushi is very right. The answer to this question is option B, is it? The value of L, the limit is 1. Does that make sense, you guys? So ye wala rule, please note this. This is a very important rule. Whenever and maybe more than half the questions that you'll be doing, that you will come across from the topic of limits, will essentially invoke or will essentially become a lot easier if we can use the L'Hopital rule. It's a very useful, very widely used rule in this chapter, right? So make sure that you understand this well. The L'Hopital rule says whenever I notice that the limit is in the 0 by 0 or the infinity by infinity form, stop at that point and differentiate both the functions in the numerator and the denominator, and then apply the limit again, right? And it's possible that it'll still be in the 0 by 0 form. If that were the case, differentiate again. So you could basically make it recursive. Bar kar sakte ho, right? You could do this again and again. Okay, so this was question number 1. How about question number 2? What question number 2, sir? I remember somebody had asked me, so why are we doing limits in IPM? IPM में तो limits आता ही नहीं है. तो मेरा जवाब बहुत simple है उनके लिए. कहाँ किसने बोला IPM में limits आता नहीं है? Who told you that? Firstly, right? IPM has never in fact released their question booklets. So then who knows what comes and what doesn't come? Secondly, all possible sources indicate that the IPM puts especially high amount of stress on the topics of geometry and trigonometry and calculus. So if anything, it should actually be a very important topic insofar as IPM is concerned. So please don't get swayed away by such opinions. Trust me, I'm only going to do the relevant topics. And obviously what we are doing is relevant not just for IPM, but also for DU-JAT, right? So everybody who's joined us live or is joining us, is watching this as a recorded session, even if you're taking the DU-JAT this session is relevant for you, right? So please do subscribe. Please do watch these videos again. All right, I'm going to shut up for a minute. I'm going to give you some time to try this yourself. Really? Okay, that's a big surprise. When x approaches infinity in limits is one of the most common question types, right? I don't know why. Is that true for everybody? Did you guys skip x approaches infinity as far as limits goes at school? I wonder how that works, isn't it? And don't you guys have board exams? Isn't it like commonly determined? Wow. Okay. More people in agreement, more people with similar thoughts. Okay. No problems. So we'll make up for that, man. There's plenty here. I mean, not plenty here, but at least quite a few questions on x approaches infinity. And nobody taught you L'Hopital rule. That's not actually very surprising because I don't know why the school curriculum doesn't include the L'Hopital rule. It must, because it simplifies questions a great deal. If you don't know L'Hopital rule, then you're going to struggle, right? In some of these tough questions, you're going to either struggle or take a lot of time, right? So simple rule है, बहुत simple rule है. L'Hopital rule is very simple. It simply says, if you have a limit that comes out in the 0 by 0 or the infinity by infinity form, differentiate and then apply the limit. That's it, right? So there's not nothing much to remember, right? But the acid testers, they have to be in the 0 by 0 or the infinity by infinity. It can't be in the 0 by infinity or the infinity by 0 form. Yeah, you can use trigonometric identities. You can also use series expansions to solve a lot of these questions. But then those are all suboptimal methods. Those are all very lengthy methods. और हमें मतलब in these MCQ exams, then we need to save time. Attempt it only if it's short. Otherwise, let it be. Okay, so here's the thought process whenever x approaches infinity. Right. The first thing is, and this is something that you guys, a lot of you are saying that you didn't do in this in school. So remember that whenever x approaches infinity, 1 by x approaches 0. Right? This is a important fact. Right? How to identify infinity form? आ जाएगा question में. It will pop up. It will pop up. I don't know what your name is. Studio Yoga. Maybe you could try logging in from your account and not from your public anonymous account, Anon account. But anyway, the idea is that whenever x approaches infinity, remember that 1 by x will approach 0, right? What that means is that, like for example, if I say find limit x approaches infinity of x plus 5 divided by 6 minus x, right? Supposing this is the question, right? So the problem here is that if you, first of all, if you put, x as infinity, this becomes infinity plus 5. So infinity plus 5 will be infinity. And then this will be 6 minus infinity. So if you subtract infinity from something, that will automatically become minus infinity. So I'm getting infinity upon infinity form, right? So one temptation will be, why not differentiate, right? Why not use the L'Hopital rule? Right? But, a smarter, a quicker, more effective method is to remember that whenever I get x approaches infinity, I should actually try and work with 1 by x approaches 0, right? So I should actually think substituting infinity in an expression is very hard. So instead, I will take that expression and rewrite it again in the form of 1 by x. Right? You will rewrite this expression, the given function, you will rewrite so that it only contains 1 by x instead of x, right? How do you do that? Like for example, if I want to create 1 by x, so what you do is you divide both numerator and denominator by x. Why? What happens if you do that? Okay, let's see. So this will become x plus 5 over x, and this will become 6 minus x over x, which means this will become limit x tends to infinity. What happens? If you split this into two terms, x upon x will be 1, and this will become 5 upon x. And here I'll end up getting 6 upon x minus 1. Right? So what happens when x tends to infinity is that 1 by x tends to 0. And if 1 by x tends to 0, this is 5 into 1 by x, no? Similarly, 6 by x will be like 6 into 1 by x. So if 1 by x tends to 0, you can directly substitute 1 by x as 0 here. What happens? I'll end up getting 1 plus 0 into 5 upon 6 into 0 minus 1. What do I get? I get 1. Numerator is 1, denominator is minus 1. So my answer is minus 1. Right? So if this was the question, very simple, right? I directly substitute in the expression. I want to, if the degree, in the numerator and the denominator is the same, very simple. Divide both numerator and denominator with appropriate power of x, so that everything can be written in the terms of 1 by x. Yeah. So usually, whenever you get a question which has x approaches infinity, this is the approach you should take. Right. First try you should do. Right. Okay. But then with x approaches infinity, there is also an important identity. There is also an important formula. Right. What is that formula? The formula says when, in fact, there are two formulae. Right, and I'm going to give you both, right? if you have limit x tends to 0, if you have 1 plus x to the power 1 by x, as x tends to 0, think what happens here. As x tends to 0, the base becomes 1 and the power becomes 1 by 0. Power becomes 1 by 0, which is like an infinity. Now, indeterminate form, right? So this is like 1 power infinity form. This is equal to e. Right? And I can also rewrite this as limit x tends to infinity 1 plus 1 by x raised to the power x. I could write it in both ways, right? Think about it. When x tends to 0, this term will become 0 and this term will become infinity. And when x tends to infinity, 1 by infinity, 1 by x will tend to 0. So this will again become 1 plus 0 raised to the power infinity form, right? So in both cases, I mean, we're still writing, both expressions mean exactly the same thing, right? Although they look different, right? So I'll have to remember this form, right? So if it is x approaches 0 wala question, then I'll use the first identity. If it is x approaches infinity wala question, then I'll use the second identity, second formula. Yeah. So in this question, that's the approach to take, right? Like for example, here what does it say? Question number 2 says, find the value of limit x tends to infinity, x plus 1 divided by x plus 2 raised to the power 2x plus 1. And you can see that, when I use this formula, both the base and the power of the exponent have x. And that's true here also. Base contains x, power also contains x. So it's tailor-made, right, to use that formula, right? Now, since this has x approaches infinity, I'm going to use the second form, right? Which means I want to rewrite this in the form of 1 plus something. So to write this as 1 plus something, you will have to rewrite this. So what will I do? I'll do 1 banane ke liye, I'll say x plus 2 minus 1 upon x plus 2. Right? This will come with practice. This comes with, how to rewrite. There is no standard formula. It comes with practice, right? So since x plus 1 can be written as x plus 2 minus 1, why did I do this? So that this becomes x plus 2 over x plus 2 minus 1 over x plus 2. Which means this becomes 1 minus this, right? So there you go. I wanted 1, I've created the 1, right? But then it should be plus. So I'm going to rewrite this. Now I'm going to rewrite this as 1 plus 1 upon minus x plus 2. Now whatever comes in the denominator, right, must go as the power, right, for this formula to be used. So I need the power to be the denominator. Denominator is minus of x plus 2, but the numerator, the power is not minus of x plus 2. So then that's a problem. So what I'll end up doing is that I will write this as the power and then raise it to 1 upon that power. And I already had 2x plus 1, right? So why do I write it this way? Because if I expand this, these powers will get multiplied. So what is in the numerator will be multiplied with this in the denominator and cancel out. You will have to 2x plus 1 in the power, and I already know the base can be written like this, right? But the very reason I write it like this is because I want to use this identity, right? And in fact, hint in this question is options also contain E. So there's a very big hint that I need to use this identity, right? So what happens? This is 1 plus something to the power the same thing, and that something as x approaches. Sorry, this is all x approaches infinity. As x approaches infinity, x plus 2 will also approach infinity, right? So this is indeed 1 plus 0 to the power infinity form. So this becomes E, but this is E. I still need to calculate the limit of x tends to infinity of this power, which is what? Which is 2x plus 1 divided by x plus 2. And so with a negative sign, by the way. Right? And so what do I do here? Now, here is where I'll repeat what we did in the previous example. I have an expression where numerator and denominator have same degree, and my expression has the limit of x tends to infinity. So what should I do? I should rewrite as x 1 by x. So here if you divide by x, you'll get 2 plus 1 by x. and in the denominator I'll get 1 plus 2 by x. So as x approaches to infinity, this becomes 2, and there's obviously a negative sign also. So this becomes e raised to the power minus, numerator is 2, denominator is 0, 1, sorry. Which means I get answer as e power minus 2. That's option B. Is this clear to you guys? No, so the limit did not move to the exponent power, right? So why I write it this way is because when you apply a limit, it applies to everything in the expression, right? So if the power also has, x, then the limit will be applied on the power also. If the base has x, then the limit will be applied to the base, right? So, I mean, you don't have a choice. You have to apply the limit to the power. It's not a how, it's a thank God it did. Otherwise, the question won't make sense. Yeah, is this clear, guys? Yeah. What about the rest of you guys? Are you guys clear with this, right? So remember, again, recap. Two things we've learned. No, when you have question which has x approaches infinity, right? So whenever you're doing questions x approaches infinity, you'll try and do when x approaches infinity, 1 by x approaches 0, right? So rewrite in terms of 1 by x. Whatever expression I have, right? And the second thing we've learned is that whenever I have a expression where both the base and the power contain x, then maybe we can invoke this rule with this identity whereby limit of 1 plus x to the power 1 by x, or limit of, and this is x tends to 0, or limit of x tends to infinity 1 plus 1 by x to the power x. Both of them will be in the form 1 to the power infinity form. So these limits are equal to e, and that's the way that we'll solve this. Yeah, is that clear to everybody? Great. Let's look at the third one. Okay. One quick answer, Hardik, racing out of the blocks. Mohit agrees. Absolutely. It's a question there. Yeah. Good. Good that you saw that, Hardik. It's a question where you're better off using the L'Hopital rule, right? You can see numerator mein log hai, it contains x and log, and denominator also contains x, and it sounds like there's a lot of work to do, right? But if you check carefully, this is limit x tends to 1. This is 1 plus log x minus x divided by 1 minus 2x plus x square, right? So as x approaches 1, simply substitute and check. 1 plus log 1. What is log 1? 10 to the power what makes 1? 10 power 0 makes 1. So this will become 0. So 1 plus 0 minus 1 is 0. And 1 minus 2 plus 1. So 1 plus 1, 2. 2 minus 2 is also 0. So you get this in the 0 by 0 form. And the moment you get the 0 by 0 form, you know that you're going to use the L'Hopital rule. Right? So using the L'Hopital rule, this will become limit x tends to 1. Differentiate the numerator. Differential of log x is 1 upon x. Differential of x is 1. Here I'm going to get minus 2 plus 2x. So what does this become? Limit x tends to 1. 1 minus x. And the x comes to the denominator. And this is, if I take the 2 common, x minus 1. Right? And you can see that numerator and denominator are same, only the sign is different. So I can cancel it out and say this is minus 1. So as x tends to 1, if I substitute, I'll get minus 1 by 2. So that's your answer option D, 1 by 2. Right? Very nice, Hardik and Mohit. Okay, how about the fifth one? No, you can do that, Hardik. Yes. You can do that, yes. Become very straightforward if you do that. Discussing fourth. I think even Hardik meant fourth. Yes, big hint. Most of you already asked me this. Question number 4. Try rationalizing. Whenever you have irrational numbers with square roots and all, try to rationalize them. See if it makes a difference. And to answer your question, Aran, you can use the L'Hopital rule as well. I mean, that also works out very nicely. Both approaches are fine. That's the beauty about mathematics, right? There's no one set way of getting the answer. But you need to be aware. You need to be aware of what, what kind of approaches work. Even our great ancestors, when they developed a lot of these amazing theorems, right? A lot of these infinite series that we learn today were developed by, probably the Kerala School of Mathematics or whatnot. And a lot of those developments are incremental, which means you need to know what your predecessor did, the kind of work that he did, for you to be then utilizing it, right? So, oh, come on, Siddhant. Now you're making up excuses. Four friends, some of our friends have already solved it. Yeah. Most of you are saying A. Indeed so. What do I have here? Limit x tends to 0, a power x minus 1 divided by root of x plus a minus, what is that? Minus root a. Yeah. So again, like I said, many ways of trying this question out. I mean, what if I rationalize? What does this become? X approaches. But rationalize karne ke liye, you need to know the formula for why we are rationalizing. Right? So first thing I'll do, I'll multiply with the conjugate and divide by the same. Right? So then it becomes a minus b into a plus b. So that becomes a square. Square of a square root is itself, and square of a square root is also itself, right? So a square minus b square into a power x minus 1 into root of x plus a plus root a. And what happens when you apply the limit, right? So it turns out that there is a formula here. Limit x tends to 0 when you have a power x minus 1 upon a, upon x. What is this equal to? This is equal to log a. And if you didn't already know that, you should. Right? This is in fact log in the base e, not log in the base 10. This is ln a, natural log of the base a. Yeah. So here that's what happens, no? I have a power x minus 1 upon x, x tends to 0. So this part will become log a. And if you put x approaches 0, so this will become root a plus root a. This will be like 2 root a. So answer is 2 into root a into log of a. Is that there in the option choices? Indeed, that's option A. Very simple question. If you use, right. And what if you use L'Hopital rule? What happens if you substitute x tends to 0? This will become a power 0, which is 1 minus 1, 0. Numerator is in the 0 form. Denominator with x tends to 0, 0. Root of a minus root of a is also 0. So this is a 0 by 0 form, which means I can rationalize, I can differentiate it. What happens? Limit x tends to 0, a power x, when differentiated, is a power x into log a. And what about the denominator? So this one is a constant, so you'll only end up differentiating this. So this is x plus a to the power half. So differential of x power n is nx raised to the power n minus 1. So here the base, the denominator has the power of half. So the power will come outside first and then you will subtract 1 from the power. So this will become x plus a to the power half minus 1. Right? Into chain rule says after differentiating it, differentiate inside the square root. What is inside the square root? X plus a. What happens if you differentiate it? Differential of x is 1, differential of a is 0. So it will remain this minus 0 because root a is a constant. So what I end up getting is limit x tends to 0, a power x into log a. In fact, 2 will also come out. Divided by, what is this? Root of x plus a, but in the denominator. So into root of x plus a. This is what happens. If you substitute x tends to 0, a power 0 is 1 log a, and as x tends to 0, this becomes root a. So there you go, 2 root a into log a. Same answer. So I don't care whether the L'Hopital rule gets used or the normal method gets used, right? Both of them are equally easy, right? You just need to believe that it will happen, it will work out, and both approaches are equally simple. I guess clear so far? Yeah, no problem, Anand. Okay, let's look at 5 then. Really? In question number 5, okay? Yep, it is the way. Yeah, question number 5 is one of those questions where, I mean, it looks like it's a question from limits, But it's actually not. It's actually a question from differentiation, right? How so? Right? Now, yeah, it's okay. 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 So, question says find the value of limit h tends to 0, f of 1 minus h minus f of 1 divided by h cube plus 3h, right? And the moment you look at this question, f of 1 minus h minus f of 1, you're immediately thinking, of, I mean, if you know it, you should be able to see this. You're immediately thinking this looks like the left hand derivative. Because what is the left hand derivative? Limit x tends to a minus. And so you do f of, in fact, left hand derivative कैसे calculate करते हैं? The easier method is to say directly say, okay, limit h tends to 0, f of a minus h minus f of a divided by minus h. Yeah, you can use the L'Hopital rule multiple times, Kashish. Yes, right. And so you can see that this is like the L'Hopital. This is like the left hand derivative because I have f of a minus h minus f of a divided by, oh, all that's missing is the minus h. So what I'll immediately write this as is limit h tends to 0, f of 1 minus h minus f1 divided by minus h. And I'll multiply this with minus h and write the h cube plus 3h separately, right? So that, you can cancel it out. Right? Now, I know this portion is actually nothing but the left hand derivative at x equal to 1. Right? So the question is, does the left hand, why specifically left hand derivative? Why not the right hand derivative? And so here's the logic, right? If a function is differentiable, it is said to be differentiable only if the left hand derivative and the right hand derivative are both equal to the derivative. Right? A function is said to be differentiable if left hand derivative LHD is equal to RHD. And that value is then termed as the differential at that point. Right? So here is this function fx. Here fx is given to me as 3x power 10 minus 7x power 8 plus 5x power 6 minus 21x cube plus 3x square minus 7, right? If this is f of x, it's a polynomial for God's sake, right? It has only x's, so it's a polynomial. And a polynomial is completely differentiable at every single point. It doesn't have a denominator, it doesn't have any roots. It will exist, this expression will exist a value. I mean, this expression will give you a real value for any real value of x, right? So this one is always differentiable. If it is always differentiable, it will be differentiable at x equal to 1. And if it is differentiable at x equal to 1, then LHD is equal to RHD is equal to f dash at 1. So since this is LHD, this must also be equal to the differential at 1. So which means you can write this expression now as f dash 1 into, what is this? Limit h tends to 0. If I knock off the h, I get numerator as minus 1 and denominator as h square plus 3. So if you put h tends to 0, this will become 0, this will become minus 1 by 3. So this is f dash 1 into minus 1 by 3. If this is f of x, then f dash 1, f dash x at 1 is very easy. Let's just differentiate it. What is f dash equal to? What is f dash equal to? 30x power 9 minus 56x power 7 plus 30x power 5 minus 63x square plus 6x. So if I want f dash at 1, this will be 30 minus 56 plus 30 minus 63 plus 6. So 30 plus 30 is 60 plus 6 66 minus 50 plus 60 119. So what am I getting? Minus 53. So this is minus 53 and this is minus 1 by 3, my answer is 53 by 3. That's option, yes, that's option D. Yeah. So good job, Hardik and Siddhant. It's indeed the way that you will figure it out, right? So yeah, trick questions are not very difficult question, right? It looks like I've done a lot of work, but I haven't, Most of it is actually in my head because I should spot that this is left-hand derivative, and then I should look at the function, and I should think, okay, this function is differential everywhere, so its left-hand derivative at a particular point should equal the differentiation at that particular point, and so I can calculate the first differential. Okay, and what about question number 6? In fact, I don't think we have time to do all the questions today. So we'll try and pick and choose, right? But for now, let's try. Let's discuss question number 6 first. What do you mean? Is it square in 6, Anand? Not sure what you mean. Is that your solution, Sarthak? Answer option A, solution, use of trigonometric identity. Is that what you're saying? No, that's not square. That's cos 2x minus 1. Think again, Hardik. If you're picking option A. Yes, Siddharth. Sin x by x, as x tends to 0, sin x by x is equal to 1. Yes. Okay, so majority of you guys, majority are saying A. Yeah? And so the majority are going to get negative marks. Because the answer isn't A. So hearing this, Mayank has changed his answer. From A, now Mayank says C. Arushi agrees. By the way, both C and D say that the limit does not exist, but C and D give different reasons for it. So is the reason given in C the correct reason? That's the question. Okay, let's look at this. I have limit x tends to 1 तो सबसे पहला difference है x tends to 1. It doesn't matter, right? And this one is root of 1 minus cos times 2x minus 1 upon x minus 1, right? And the moment I look at this, I know the trigonometric identity, no? 1 minus cos 2 theta is 2 sine square theta. Right? This is clearly the identity that everybody is thinking about, right? And so obviously I'm going to use that. So I'll be tempted to say, okay, this becomes limit x tends to 1. I'll say root of sine square x minus 1 divided by x minus 1. And immediately I'll say, okay, this will be limit x tends to 1 sine of x minus 1 divided by x minus 1. As x approaches 1, x minus 1 approaches 0. So this is in the sine 0 by 0 form, which is indeed equal to 1. So only problem is the 2. I forgot the 2, right? So that 2 will be left root 2 into this. So answer will be 1 into root 2. Yeah. So which is why most of you said answer is option A, right? So which of these steps is wrong? Because if the answer is not A, one of them will be wrong, right? So is step, this is step 1, this is step 2, and this is step 3, right? Point out which of the steps is wrong, which step is incorrect or faulty. गलती कहाँ हुई है? Yeah? No. Most of you are saying the mistake is in step 3. No, step 3 is not wrong. Step 2 is wrong. That's the problem, right? Because you don't know why you went wrong. Step 2 was also wrong. Okay, here's why. Okay, the logic here is that if I take a square root, the first thing you should notice it's a square root of something inside the square root. What do I have? 1 minus cos of theta. 1 minus cos of some angle, right? Now I know cos of any angle, the maximum value it can take is 1, right? But it will usually be 1 or less than it, which means if I subtract 1 minus something, then this value inside the square root will always be positive, correct? At best it will be 0. So which means the square root exists. But remember that once you take the square root, the sign outside is the positive sign. Nothing is written means it's the positive square root. Correct? It's important to remember that this expression has the positive square root, which means that the numerator must never be negative. It should never allow a negative value, right? So when I come to step number 2, if this square root is written as root 2 into sin x minus 1, as x approaches 1, what happens when I put x as 0? What will happen? This will become sin 0 minus 1, right? Which means, can it be sin 0 minus, what is it? Sine of a negative angle, it will be negative sign. Which means the numerator can become negative now. In fact, if x tends to 1, what if it tends to 1 from the negative direction? What if it is 0.9, for example? If I put 0.9, 0.9 minus 1 is minus 0.1. And sine of minus 0.1 will be minus sine of 0.1. Which means it will take negative values. And that's a problem because the numerator must always be, remember, it's always a positive square root. So step number 2 is incorrect, right? So how do I correct it? You basically correct it by saying this should actually be limit of x tends to 1 root 2 into mod of sin x minus 1. Right? This is where it becomes tricky. I will have to put a mod because I will say as x is positive, as it is approaching from the positive direction, no problem. But as x approaches from the negative direction, there is a problem. Right? And even in fact, the moment you notice that, you'll think, oops, positive, negative approaching means left hand limit and right hand limit. So immediately stop and say, okay, let's split and calculate the left hand limit and the right hand limit separately. Right? Let's try doing that. What happens if you calculate left hand limit? What if I am approaching 1 from the negative direction? Right? If I'm approaching it from negative direction, what will this become? Sine of 0.9 minus 1 approximately, right? And if it is 0.9 minus 1, it will be negative. And when when the angle is negative, the sign will also be negative. And so what is contained inside the mod is a negative value. So what will the modulus do? Modulus multiplies a negative number with a minus 1, right? So this will actually become root 2 into minus sine x minus 1 upon x minus 1. And you can see that if you write it this way, sine x minus 1 by x minus 1 is 1. So my limit value will be minus root 2. Whereas, if you take the right hand derivative, right, if I approach x from one from the positive direction, then this angle will be positive. 1.1, for example, or 1.05. 1.05 minus 1 is positive. Sine of a positive angle is positive, which means the modulus will do nothing. So you'll end up getting root 2 into sine of x minus 1 divided by x minus 1, which is indeed equal to root 2. So you can see that the left hand limit is negative, but the right hand limit is positive. And so the limits are not equal. So the limit does not exist for that reason. Does that make sense to you guys? It's a little confusing, right? It's a little confusing for pretty much this reason, right? Again, let me explain this point again. This kind of a problem is a tricky. It's like a double-edged sword, right? It will seem like a very easy question, but then, oops, most people will make a mistake. Why? So remember this. Whenever you see a square root, you should look at the sign outside the square root. Outside the square root, I have no sign, which means for all practical purposes, here it says that consider only the positive square root. Do not allow it to be negative. I need to ensure that, right? Even if I use a trigonometric identity, I should ensure that the outcome of the numerator should remain a positive value, right? So what I do is, when I take a square root, first step, did nothing, simply applied the trigonometric identity. Second step, when I evaluate this square root, root 2 will come outside. But if I do square root of a sine square, now imagine square root of sine square something, theta, right? Now, most of you will readily say this will be sine theta, right? But what if it was square root of sine square 210 degrees? What if it was sine square of 210 degrees, right? So then if you knock it off, if you write this as sine 210, it turns out sine 210 is sine pi plus 30. And sine pi plus theta is negative. So this will be minus sine 30. And what is minus sine 30? Minus 1 by 2. So you'll get minus 1 by 2, which is not possible. Why is it not possible? Because it contains positive square root. It can't be negative. You see the problem? The problem with directly saying square root is equal square root of a sine square theta is sine theta is incorrect, right? So you should never do this. So what should you do? Whenever you have square root of a trigonometric identity, you do mod. You say put a mod, na? If it is positive, mod will do nothing. If it is negative, mod will automatically make it positive. So here that's what I did. Instead of doing step number 2 like this, instead of directly knocking off the square root against the square, I actually put a mod against it. And the moment I put a mod, I'm thinking when the value inside the mod is positive, which happens when I approach 1 from the positive direction, because x will take a value always greater than 1. If x takes values which are greater than 1, this value inside the sign will be positive. And when you consider sine of a positive angle, it will remain positive. So sine x minus 1, mod of sine x minus 1 will be x minus 1. Sine x minus 1. So here there is no change because you are approaching it from the positive direction, right? But when you approach it from the negative direction, something like 0.95. So 0.95 minus 1 will be minus 0.05. And sine of negative 0.05 will be negative of sine. And so this becomes minus root 2. Yeah. So this is the explanation, right? It's a little hard. This is a really tough question because most people will make mistakes. Sin x by x is 1 when the limit approaches 0. Yes. Yes, Siddharth. That's correct. No, not when the limit approaches 0, when the angle approaches 0. So you're basically saying limit x tends to 0, sin x by x is 1. But this can also be rewritten as limit x tends to 1, sin x minus 1 divided by x minus 1 is also 1. Same form, right? If you substitute x minus 1 as y, this will be sin y by y as y approaches 0. So it's same thing. Right. So this was question number 6. I thought a very interesting question, this one. Okay, let's move things ahead. I think 7th is an easy one. I think I'm going to leave it for you guys to try yourself. Let's look at question number 8. Let's look at question number 8. Try question number 8 now. Yeah, I can see a lot of you guys are subscribing. Are subscribing today. If there are any people who haven't subscribed yet, I'd really ask you guys to do so right away. Make sure that you subscribe and click the bell icon, because we're doing the session almost every single day nowadays, and almost like every second or third day, something or the other is going up live on the website. So make sure that you guys like, subscribe, and share this video amongst your friends. Yeah, if you like what we're doing today, please let your friends know as well. Question number 8. Yep, Siddharth. Yes, that sounds like the right thing to do. Use L'Hopital rule in this question. See how it helps you make this, how it makes this question easier to solve. Okay, good stuff, you guys. I think अब L'Hopital तो समझ में आ गया आप लोगों को, right? You guys are getting a hang of L'Hopital because you can see that here. Okay, let me look at the question first. Eighth, I said, right? Yeah. So this is limit x tends to 0 e power nx minus 1 plus nx plus n square x square by 2 whole divided by x cube. Right, so if I put x tends to 0, this becomes 0. Denominator is 0. Numerator is also e power 0 will be 1. 1 minus 1 becomes 0, and these two will also be 0. So clearly 0 by 0 form. Right? But so if I differentiate this, then this must be equal to limit x tends to 0. Differentiate this numerator, e power nx will become n into e power nx, and differential of this bracket will be n plus n square x. Divided by x, 3x square. Sorry. And again, I can see that as x tends to 0, this will be n into 1. N minus n is 0. This will be 0 and this is also 0. So again 0 by 0 form. Again differentiate it. So limit x tends to 0. I differentiate this again. This will become n square into e power nx. Now differential of this is 0. Differential of this will become n square. Again same problem. N square into 1 minus n square. 0 by 0 form again. Right? So the only way out is again to differentiate. So limit x tends to 0. And now n cube into e power nx is left because this will go away, divided by 6. And now if you substitute, you calculate the limit as x tends to 0, the power becomes 0, e power 0 is 1. So this is n cube divided by 6. That's the answer, right? So 3, if you apply L'Hopital rule 3 times, gives you the answer. Yeah? But obviously you need to know that, right? So this is one way, one problem type where you need to apply L'Hopital 3 times, right? Let me show you one more like this, right? Look at question number 12, for example. Question number 12. It says let given expression fx is given. It says x is not, x can't be 0 because it's in the denominator. And the value at x equal to 0 is 1. So f of 0 is 1. Right? And this is an important piece of information because it says f of 0 is equal to 1 means the function value exists only if it is continuous. And when is it continuous? Only if its left hand and right hand limits are equal, which means the limit exists. So here what you can do is you will say the limit value of the limit as x tends to 0 will be equal to 1. And you need to calculate the value of a and b so that happens. Right? See if you can figure it out. I'll give you a couple of minutes. See if you can do question number 12. Not so straightforward, no? No, don't need to be sorry. It's a tough question. In fact, मतलब अच्छे से देख लो इस question को. This is the type of question which you read and you be like, yeah, this is a nice question, but I should leave it alone, है ना? This is the kind of question where if I talk in batting parlance, then you need to become Rahul Dravid. Well, left कर दो, छोड़ दो, right? Don't need to attempt this. It will take time. But let me still show you how it's done, right? I mean, if you know how to do it, actually it's not very long either. हो सकता है. No, Siddhant, that doesn't. If f of 0 is 1, f dash of 0 doesn't need to be 1. No, that's not necessarily true. Yeah, so what is the question saying? That it says fx is equal to x into 1 plus cos x, 1 plus a cos x rather, minus b sin x whole divided by x cube. Yeah, and the question says f of 0 is 1. I'm going to write this here. F of 0 is 1, which means the function value exists at x equal to 0. But what happens if you put x equal to 0 here? 0 ho jayega, this term becomes 0. And sin x is also 0. 0 minus 0 is 0. 0 by 0. So you can see that this is in the 0 by 0 form. Right? And since f of 0 is 1, the limit must exist. This implies that LHL is equal to RHL is equal to f of 0. Right? So limit exists. So then if the limit exists, let me calculate that limit. No, limit x tends to 0 of fx should be equal to 1. Which means that limit of this as x tends to 0, limit of this will be in the 0 by 0 form. So let me, even before I start the question, even before I start limits, differentiate kar dete. Let's differentiate both numerator and denominator. If you differentiate the numerator, x into this, so I'll use the chain rule. Differentiation of a into b will be a into b dash plus b into a dash. So x into differential of this. What is differential of this? Minus a sin x plus 1 plus a cos x into differential of x, which is 1, minus b sin x, differential of b sin x is b cos x, whole divided by 3x square. Right? And so this limit must be equal to 1. Right? Now let's apply the limit and see what happens. If you put x tends to 0, denominator is in the 0, numerator will be 0 into something 0, 1 plus a into cos 0. What is cos 0? Cos 0 is 1. So this becomes 1 plus a, 0 plus 1 plus a minus b divided by 0. This is what I have. So clearly, you'll make a weird sort of assumption here, right? You'll say, okay, but this must exist. What I'm getting is numerator is a finite value. What is the numerator? 1 plus a minus b. So numerator is not 0 or infinity, but denominator is 0. Oh, so this limit should be actually equal to infinity. But then it's not infinity. What is the limit equal to? 1. So when will this limit be determinant? Only if this is this must be in the 0 by 0 form, right? Only then I can again differentiate, just like we did in question number 8. You could differentiate again and again, because even after differentiating once, if you evaluate the limit, it comes out in the 0 by 0 form, right? So same conclusion here, right? That since this is equal to 1, it must be in the 0 by 0 form, and for that to happen, the numerator must be 0, which means 1 plus a minus b is equal to 0, which means b minus a is equal to 1. That is equation number 1. Does everybody understand or agree with me here? What am I saying? I am saying if this limit exists, right? This limit is in the something upon 0 form, right? Or in the 1 by 0 form. 1 by 0 limits are not finite, they'll be infinite. But this limit is equal to 1. So that will only be possible if it's in the 0 by 0 form. So numerator should also be 0, and which happens when b minus a is 1, right? Now that I'm saying this is in the 0 by 0 form, immediately means that this limit must be, again, we can determine this limit. Let me write this again, limit x tends to 0. Now let me differentiate this, because this is also in the 0 by 0 form. We've ensured that. So if you differentiate this again, what do I get? X into minus a sin x. So differentiate this, minus a sin x into differential of x, which is 1, plus x into differential of minus a sin x, which is minus a cos x, plus differential of 1 plus a cos x. Let's differentiate. Differential of 1 is 0, and differential of a cos x will be minus a sin x, and differential of minus b cos x will be plus b cos x, sorry, b sin x, whole divided by 6x. Again, if you substitute, what do you get? Minus a 0, so 0, plus 0 into whatever, minus a into 0, plus b into 0. Oh, okay, it's anyway in the 0 by 0 form. It's anyway in the 0 by 0 form, which means I should again differentiate. Let me do that again. X tends to 0. If I differentiate this again, what happens? Minus a cos x. And if I differentiate this, this is like minus a into x cos x, right? So I'll break it down. X into minus sin x plus cos x into 1. Yeah. And here what I can do is I can write this as b minus a into sin x. So if it is b minus a into sin x differentiated will become cos x. So this is what it becomes, whole divided by 6, right? And now know that the denominator is not 0. Right, okay. So if you are asking me, how did I equate this to 1? See, if the limit is in the 0 by 0 form, then L'Hopital rule, when applied, will make it a finite limit. It will make it into a determinant form, in which case the limit will actually be equal to, if the limit exists, the limit will actually be equal to the function value, no? And the function value is given to me as 1. So then I will say that that should be the value of the limit, right? In fact, this step pe bhi wahi karunga main. If I substitute x equal to 0, what will happen? Minus a into cos 0 is 1. So minus a into 0 plus 1 plus b minus a into 1 divided by 6. Right? This is what I'm getting. Right? Now, again, if this limit exists, it must be equal to 1. Right? I'm equating it. Remember, even though it's not in the 0 by 0 form, I'm saying it must be in the 0 by 0 form, first of all. And if it is in the 0 by 0 form, then my conjecture is that if I use the L'Hopital rule again, then it will become, the limit will come out, right? We will be able to calculate the limit, right? And if we are able to calculate the limit, then the limit exists. And if the limit exists, it must be equal to the function value. That's the whole property of limit, right? What is limit? As x tends to a particular value, the value of the function approaches another value. And that's the value of the function, right? So whenever limit exists, it must be equal to f of a. So here, f of 0 is 1. So we'll equate here also it is equal to 1. Here also I'll equate it to 1. What happens here? Minus a is minus 2a. And this is plus b minus a is equal to 6. So my equation actually becomes b minus 3a is equal to 6. So equation 1 and equation 2, I can I can simultaneously solve equations 1 and 2. Right? That'll give me the answer. B minus A is equal to 1 and B minus 3A equal to 6. Now all I need to do is solve them simultaneously. And what does the question ask? Before I solve, I'll look at the question. Question says value of A and B. So दोनों निकालने हैं, just solve it simultaneously. Basically subtract it. Do equation 1 minus equation 2. If you do 1 minus 2, you'll get minus A. B and B will get cancelled out. Minus A minus 3A will be equal to 1 minus 6, which means 3A minus A, 2A. A will be minus 5 by 2. If you take this value, substitute there, B will be 1 plus A. So 1 minus 5 by 2. That's like minus 3 by 2. So answer is minus 5 by 2, minus 3 by 2. That's option C. Yeah, you can do that. You can substitute B minus A as 1, you'll get the value of A. Right? But you can see why I said this question. Please leave it alone. है ना, ये question करना ही नहीं है ना? Nobody has this much time, boss. It's just too much mehnat. This is not something you will ever attempt in any exam, unless it's CBSE. Unless you need to get 100 out of 100, right? नहीं तो नहीं करना है इतना. Nobody has time, to waste on such problems, right? So even though I did show you how to solve this question, if you still have problems or doubts, no, छोड़ देना यार. Please leave this question, right? It's a question you're better off letting go. Okay. Some other questions then. Okay, let's look at something which is slightly different. Yeah, look at question number 17. But wait a minute. Before we do 17, can you try 14th? I sense that x approaches infinity is not a favorite limit. In fact, I'll also do 11 and 17. Do question 11 and question number 17. Sorry, not 17. 11 and 14. Sorry, guys. First do question 14 and then do question number 11. Okay, some answers coming in for question number 14. Most of you are saying C. ठीक ही लग रही बात फिर. Right? Remember, it's right? So I have limit x tends to infinity. Square root x square क्या है? X square plus 1 minus square root of x square minus 1. This is the one, right? Yeah. Thing is, whenever you have x tends to infinity, you know you want to rewrite it as 1 by x, right? And here, the moment I see irrationals, I can also think, let me rationalize, no? So let me multiply and divide by the conjugate. So root a minus root b का conjugate होगा root a plus root b. And you know why I do this is so that a minus b into a plus b becomes a square minus b square. And then this expression, right? So what happens is x square and x square cancels out. 1 plus 1 becomes 2. So this becomes 2 times limit of x tends to infinity. I'm getting 1 upon this, right? And here's where you pounce on that opportunity, right? Because what I want is to make, again, is I can't substitute x tends to infinity, but we can substitute 1 by x tends to 0. So I want to divide, divide by x. How do you substitute x tends to infinity? You can't. I don't know how you can substitute that. But I do know that we can substitute 1 by x tends to 0. So divide by x, numerator will become 1 by x, denominator. So when the denominator is divided by x, each of these will be divided by x. Either x se divide karenge, the square root can will become x square, right? So dividing the square root by x square, and this will become 1 plus 1 by x square, and this will become root of 1 minus 1 by x square, right? And you know when x tends to infinity, 1 by x tends to 0. So what will this become? 0 upon 1 plus 1. Obviously inside the square root, right? So square root of 1 plus square root of 1 will become 2. But numerator is 0, no? So this limit will be 0. Indeed, option C. Yeah. So again, you can see, if you remember this trick that whenever you have x tends to infinity, you should rewrite it at this as 1 by x tends to 0. So you want to make 1 by x in the expression. Okay. And try the 11th one. Siddharth, are you saying we can directly substitute in this expression? कैसे करोगे? How do you substitute x tends to infinity? Square root of 1 plus infinity will be what? I'm not sure that I understand what you mean. How do you substitute x equal to infinity here? So So then this will be infinity minus infinity, and you're saying infinity minus infinity is 0. Please don't do such things, yeah. Infinity is an indeterminate value. You can't subtract infinity from infinity. You can't. You can't. No, you can't. You can't do any of those things. No, you can't. You can't. Right? You can't subtract anything from infinity. You can't subtract infinity from anything. In fact, infinity minus infinity, right? For example, what is infinity minus 1? Infinity. Is this even a logical equation? It's like saying x minus 1 is equal to x. ये क्या मतलब हुई? You see what I mean? So if you start doing such things, no, arithmetic will become very weird. Algebra will become very weird. So don't. What you can do, yes, you could have directly divided it by x. You could do that. Absolutely. You could do that. What would that do? 1 plus 1 by x square, 1 minus 1 by x square. So then it will become 0. Numerator will become 0. But then it will become 0 by 0 form, no? Kriti? If we directly divide it by x, then you'll say it will be this divided by 1 by x, na? If you directly divide it by x, this will become limit x tends to 0 root of, it will be like root of 1 plus 1 by x square minus root of 1 minus 1 by x square. But then there will be a 1 by x in the denominator also. So if as x tends to infinity, 1 by x tends to 0, this will be in the 0 by 0 form. So it doesn't really help. So you can't directly, in theory, that's an approach you should be trying, but in practice, it will get you to the 0 by 0 form. So it doesn't really help you solve the question. Okay, batch 2015. I wonder who that is. Class ends at 8, my friend. Another 13 minutes or so, 15 minutes, let's say. And you guys are marking 11th question as either A or D. A or D. That's okay. If the limit is equal to minus 1, then what's the value of A, right? So it's again not that typical a question. If the limit of x tends to a power x minus x power a divided by x power x minus a power a. Isn't that the, if this is equal to minus 1, right? First step I'll substitute and check what happens when x is tending to a power a minus a power a, 0, divided by a power a minus a power a, also 0. So this, I know this expression is in the 0 by 0 form. And I know what I need to do, right? I need to use the L'Hopital rule, right? So using the L'Hopital rule, I'm going to write that. This will become limit x tends to a. Let's differentiate. Yeah. Differential of a power x is a power x into log of a. Differentiation of x to the power a constant is equal to a x power a minus 1. And differential of x power x, can't directly write it, right? So I'm gonna do this here. Let y be x raised to the power x. We'll have to take a log. Log y will be x into log of x. And you want the value of y dash. So differentiate both sides. So this will become 1 by y into y dash. If you differentiate this, log y, log of anything will become 1 upon that into differential of y is y dash. This will be, so here I'll use the chain rule, say x into differential of log x is 1 by x plus log x into differential of x, which is 1. So what this becomes is 1 plus log x, right? But then y dash will be 1 plus log x into y. And what is y? X power x. So y dash will be x power x into 1 plus log x. So I'm going to take this and I'm going to substitute this in the denominator. So this will become x power x into 1 plus log of x. Okay, does this help? If I substitute x tends to a, what happens? A power a into log a minus a into a power a minus 1. A into a power a minus 1 will be So this is like a power a into log a minus a into a power a minus 1 divided by a power a into 1 plus log a, which is like a power a. This is also a power a, right? So this becomes log a minus 1 divided by a power a into log a plus 1. So I can see a power a cancels out. And the question says this limit is equal to minus 1. So I can then cross multiply. No? I can say log a minus 1 is equal to minus log a minus 1. So minus 1 goes away. So 2 log a is equal to 0, which means log of a is equal to 0, which means a will be equal to 10 power 0, taking an anti-log 1. Hence the answer is a is equal to 1, which is option A. Exactly. What do you mean squared? Which denominator is squared? Not sure I understand. Why a square? This is question number 11. No, I've copied it right. Some of you are saying it copied wrong. Some of you are saying it is right. Where is there a square? In question, it is squared. What am I reading wrong? X tends to a power x minus x power a divided by x power x minus a power a is equal to minus 1. This is a power a, my friend. This is not a square. This is a power a. You guys are reading it wrong. Or is it given wrong? Okay, maybe it's given wrong. Okay, my bad. I mean, I know it doesn't actually matter because either ways it's a constant, right? Whether it's a power a or a power 2, it really doesn't matter. Yeah, so okay. This was question number 11. Yeah, I know it's been given as a square. It should be actually a power a, but it doesn't matter. Right, let's come back, circle back to these problems. Yeah, I wanted to discuss 17th. Yeah, 17th. That's an interesting question, right? Where it's a different function. We've discussed function types. We've done the logarithmic function and how to deal with logs, how to deal with moduli, modulus function, absolute value function kar chuke hain. We've also touched upon the exponential problem types, exponents. Yeah. But then this is something we haven't touched, something called the greatest integer function, right? Which is the one which is coming in question number 17th, right? In the interest of time, I'm going to directly solve this. How will it come out to be 2, Arhan? If it is a square, okay. My bad. Please make a correction, guys. on this question, the denominator should have a power a, not a square. Right? Please make that correction. My bad. Right. We're talking about question number 17. It says fx is equal to greatest integer of x square plus 1. It defines the square bracket of x as the greatest integer function. It is the greatest integer less than or equal to x. If you read this carefully, it's very neatly defined in the question. Right? Greatest integer is the function will return the greatest integer value which is less than or equal to x. And the question asks me for when f is continuous on the interval 1 to 3, right? So for what, for how many values is it continuous in the interval 1 to 3? I need to check continuity here. Right? It's a very hard problem. It's a very hard question, right? Anand, I'll have to check that up. I don't know. I'll have to calculate, because if it is not if it is a square, then it's not in the 0 by 0 form. Then I'll have to calculate it, right? So let me come back to that later. Yeah. Yeah. So for now here, fx is equal to greatest integer of x square plus 1, where the square bracket denotes the greatest integer function. So let's first understand the greatest integer function. In this question, the important thing is to understand what is GIF, right? Now, understand this. This returns the greatest integer value less than x. Right? What that means is, first, if I hide this, the outcome of greatest integer of x will always be less than or equal to x. It can never be more than x, right? So the first thing is that the outcome of the square bracket function, the greatest integer function, is that it will give you a value which is either equal to your input or less than your input. It can never be greater than input. Okay, number one. Number two, it also gives you an integer value. It doesn't give me a number with a decimal portion. It only gives me a number which is integer. And if it can give many integer values, it will give you the greatest value, right? Example, supposing I ask you what is the greatest integer of 5.3, right? What it will do is it will give me 5.3 se chota. How many integers are less than? Think about integers. Integer values less than 5.3. Right? The moment I start thinking, I'm thinking, okay, less than 5.3, 5, 4, 3, 2, 1, 0, negatives. So there are infinite number of such values, but it will return the greatest value. Which is the greatest value here? 5. Similarly, if I ask you what is the greatest integer of 15.342, you will say, oh, no problem, 15. Yeah. So first rule, right? The GIF for positive values, it drops the decimal. Important, no? For positive values, what will it do? It will take away the decimal. It will remove it. So 5.3 में से 0.3 हटा देगा. 15.342, it will remove the 0.342. If it is 6.289, it will remove it and say 6. Okay. That's for positive values. What about negative values? Let's take negative values. Minus 3.46. Again, let's do the same thing. We want integer values which are less than minus 3.46. Let's think of the first integer value which is less than minus 3.46, right? Now, to understand this better, this is origin. This is minus 1, minus 2, minus 3, minus 4. So where will minus 3.46 be? It will be between minus 3 and minus 4. It will be somewhere here. Now you want an integer value that is less than minus 3.46, which means it should be to the left of minus 3. So to the left, which is the first integer that comes? minus 4. In fact, minus 4, minus 5, minus 6, all of these will be eligible. But since you want the greatest value will indeed be minus 4. Right? So Kashish is asking me, what about greatest integer of 5.96? It will still be 5. It has to be less than. It can never be greater than. So for integer positive values, it will drop the decimal. It will remove the decimal. It doesn't round up. Remember, rounding off nahi kar raha hai. It just removes it. But for negative, it's even more weird. It removes the decimal, but then decreases it by 1. Right? Remember this. For negative value, it drops the decimal and reduces by 1. First, it will remove the decimal and then it will decrease it by 1. So, if I have greatest integer of minus 5.49, you will say minus 6. Why? It will first remove the decimal, then minus 5 ko ek 1 se ghataoge, minus 6. Right? I hope you understand what this means. What will be the greatest integer of 0.3? What will the greatest integer of 0.3 be? What do you guys think? Spot on. This should be 0. It will simply drop it. Positive value, hai na ye? So for positive values, it will drop the decimal. The 0. That's your answer, right? So everybody understands what GIF does, correct? Hopefully, everybody understands what the GIF does. So I'm going to take this away now. Okay. Now, in fact, I'll linger on for one more minute on this. The greatest integer function basically has a curve which looks like this. Graph looks like this. It's called a step function. Right? Why? Because think about it. 0.1, GIF at 0.1 is 0.0. 0.2 is also be 0. 0.3 will also be 0. 0.4 also 0. 0.9 also it will return 0. But the moment I make 1, it will return 1. And then 1.1 will remain 1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9. And then moment I make it 2, it will return 2. And then it will remain 2 till 3. And then it will remain 3 till 4. And so on. Right? So step function, right? Now, this graph is very important in this question because where is this function discontinuous? Where does the function become a discontinuous one? Right? Wherever it takes integer values, wherever x equal to 1, 2, 3, 4, at integer values. This is an important thing. Right? The greatest integer function is discontinuous at integer values. So, if this is true for GIF of x, it will also be true for GIF of x square plus 1, right? Which means even when I consider greatest integer of x square plus 1, this will also be discontinuous at integer values. But then, the question says check its continuity in the range 1 to 3. So, what is f of 1? Put x equal to 1. I'll get greatest integer of 1 square plus 1. That's 2. And greatest integer of 2 is also 2. Right? Similarly, what about f of 3? This will be like greatest integer of 3 square plus 1. 3 square is 9. 9 plus 1 is 10. Greatest integer of 10 will be 10 itself. So from 2 to 10, if I start traveling from 2 to 10, right? How many integer values will I cross? So integer values between 2 and 10 will be which ones? 3, 4, 5, 6, 7, 8 and 9. So how many values am I crossing? 1, 2, 3, 4, 5, 6, 7. So since I'm crossing 7 values, there will be 7 points of discontinuity. Right? In fact, not just the 7, even the 8th one we will count. We will also count 10. Why? Why not? Why don't we count 2, but why do we include 10? Socho. Think about it. Because if I put x equal to 1, what happens? 1 square plus 1 is 2. Now try putting f of 1.1. Let's see what happens. 1.1 square is 1.21 plus 1, 2.21. What is greatest integer of 2.21? 2, which means it's still remaining 2. So there is no break, no, in the curve. So there won't be a break at 1.1. When it goes from 1 to 1.1, there is no break in the curve. So it's continuous at x equal to 2. But what about x equal to 10? So let's try and put f of 3. I know it's 10. So what about f of, let's say, 2.9? So 2.9 square plus 1 and GIF of that. Now what is 29 square? Anybody remembers this? 861. So this becomes greatest integer of 8.71. What is greatest integer of 8.71? 8. But f of 3 is 10. In fact, 2.9 to show there will be a 2.95, 96, 91. My bad. But it doesn't matter. So 8.41 plus 1 is 9.41. So the greatest integer value I'll get is 9. But at 3 it becomes 10, no? Which means all of these, for example, if I do f of 2.8, yeah, 2.8 squared is, I'll have to calculate this, 1.96 into 4. 2.8 square, 4 into 1.96 plus 1. What do I get? 4 6 are 24, 4 9 are 32, 38, 4 4 is 7.84. Plus 1. So I'm going to get 8. So you can see that some values are 8, some values are 9, but it will never be 10. It will never give me a value which is 10 point something, right? And for that reason, this function will be discontinuous at even 3. Yep. So there you go. How many points of discontinuity? All points from 1 to 3. Sorry, from, all values of x which give you the function value as 3, 4, 5, 6, 7, 8, 9 and 10 will be discontinuous. So there are 1, 2, 3, 4, 5, 6, 7, 8 values, 8 points of discontinuity. Answer to question number 17, right? Also a very tough question. Also a question we should leave for shock, right? No questions asked. Okay. All right. That's all I have for you guys in today's session. I hope kuch naya seekhe. I hope you learned something new. If you like this session, please let your friends know. Please like, share, and subscribe to our channel. Please spread the word. We want to reach out to as many people as we possibly can to make this, as widely spread as possible. Right? All right. You guys have been great. Thank you. Thanks for your time. I'll see you guys next week. Have a good day. Stay safe, and bye bye.